If you listened to the last video, I said we were going to do something with momentum and energy, which we will, but I decided to do one more example with just momentum. So we have 3 people on a raft. This raft is 120 kilograms. They're in the middle of a pond. They decide to go swimming, and they all jump off the raft at the same time and from evenly spaced positions. So one person, just for simplicity's sake, I'm going to say this person, M1, has a mass of 62 kilograms, and they jump off at a speed of 12 meters per second. Now, if the 3 people are spaced evenly in 360 degrees, they have to be 120 degrees apart. So the next person will jump out this way. The angle, if we imagine our coordinate system right here, the angle here will be 120. So this person, mass of 73 kilograms, jumps off at a speed of 8 meters per second. The third person, so again, another 120 degrees. The third person, mass 55 kilograms, jumps off at 11 meters per second. We want to know the speed of the raft. So at what speed does the raft drift from its original position? Now, this is considered an explosion. Again, not the Hollywood version, of course, but because all 3 people had just been floating on this raft, and now they come apart, this is why it's considered an explosion. So our system overall includes the raft and 3 people. So essentially 4 objects. The total mass is mass of person 1 plus mass of person 2 plus mass of person 3 plus the mass of the raft. So let's call the raft object 4. Initially, they are one big object, just floating. Because any motion that occurs for the raft overall is based off of all these people jumping off at the same time, we can say that momentum is conserved. So the momentum is mass times velocity. I'm calling it mass total because initially everyone, the mass and the raft, everything was together. And then finally, I have to break this into all 4 objects. The nice thing is I just keep adding the individual momentum, or momenta, together. It looks a lot bigger, but it ends up not being too bad. So let's walk through it. We can see in our picture that person 2 has a Vx final and a Vy final. Similarly, person 3 has a Vx final and a Vy final. We need to find the potential Vx final and Vy final for the raft. So we're going to be looking for V4 x final and V4 y final. This is what we're going to look for. So this one's 2, this one's 3, this one's 1. x4 is the raft, and that's what we'll look for. So I'm going to use this equation. First, let's look at the x direction specifically, meaning just x components of all of these velocities. The mass is a scalar, so we just multiply by the mass. Okay, I know, or I'm going to assume, since the problem says the 3 people are just floating on the raft, I'm going to assume the initial velocity is 0, that there's no specific speed and direction. Now, if you've ever just been floating in a pond, you might have a general motion because of wind or whatnot, but we're going to ignore that. So that tells us that the initial momentum of the system is 0. So all of the x components are going to have to add up to be 0. So object 1 was the first person I drew. They have a mass of 62 kilograms, and I've chosen their direction to jump off as the x direction specifically. Again, I did that just so one of the velocities was all in one direction. Person 2 has a mass of 73 kilograms. So up here, this person's velocity is 8 meters per second. If it's 120 degrees this way, then to finish up the 80, this is a 60-degree angle. So the x side points to the left and is 8 cosine 60. So that tells me the x component of the velocity for this 73 kilogram person. Okay, person 3 has a mass of 55 kilograms. Their velocity is 11 meters per second. Everything is separated. All of these individual velocity vectors representing the people are 120 degrees apart. So if person 2's velocity made 60 degrees with the horizontal, then so does person 3. So their x component is to the left, and it's 11 cosine 60. So to the left, I'm going to put the negative sign to represent that direction. And then 11 cosine 60 is the x component. So this accounts for all 3 people. And now we need to put in the raft. The raft has a mass of 120 and potentially has an x component of velocity finally. We're trying to figure that out. Well, we have everything except for this x component of velocity finally, so let's see what we get. So let's see. I'm just going to plug everything in. So I'm getting negative 1.2458 meters per second. And of course I don't need that many sig figs, but I'm not going to round yet because I'm not to my final answer. What this tells me is that the raft overall ends up heading to the left. Okay. To find the y component, so I'm going to draw for the raft. I now know it's headed to the left this fast. So this is my x component of the raft's velocity. To figure out if it has a y component, we need to go through conservation of momentum again. We still have zero momentum to begin with in the y direction, but now I'm going to look specifically at y components for all these velocities. So the first person has a mass of 62 kilograms, but the way I've drawn the picture, they do not have a y component of velocity. I did that just to simplify a little piece. Our second person has a mass of 73 kilograms up here. Their y component of velocity is upwards. It is 8 sine 60. The third person has a mass of 55 kilograms. Their y component is downwards, so negative. This side's going to be 11 sine 60. So 1, 2, 3, that accounts for all three people. Now we have the raft. So the raft's y velocity, if it has one, oh, I forgot my 11 right here. Sorry. So I'm getting positive 15155. So I can draw this y velocity upwards at 0.15155. The problem wants to know the speed of the raft. So essentially the magnitude of this raft's velocity. So Pythagorean theorem, the square root of the x side squared plus the other side squared. I'm getting 1.3 meters per second. Now we can totally solve for speed because we can put the three people wherever we want and come up with the same speed of the raft. Direction, they would have had to tell us exactly where the three people were in order to have a specific direction. Here, this gives it a direction relative to my picture, but that could be different than someone else's picture. So the raft ends up traveling at 1.3 meters per second because of the conservation of momentum, these three people jumping off. If you've ever been in a canoe or a little boat, if you try to jump out, you don't enjoy the process. I experienced that, unfortunately, as a kid, jumping out of a canoe. I was the only one in the canoe, and it took with it part of my shin, because, of course, as I pushed back, the canoe moved one way and I moved the other. So this is situations that we are probably somewhat familiar with, just in different contexts.